Materials and resources. Building life cycle impact reduction.
Introduction. The intent behind adding this credit for LEED was to encourage adaptive reuse and optimize the environmental performance of products and materials. The Building Life Cycle Impact Reduction credit can be used to gain anywhere from 2 to 6 points depending on the type of construction and the requirements the project fulfills. Behind the intent. Over their lifetimes, buildings have local, regional, and global environmental effects. Life Cycle Assessment (LCA) examines as many of these environmental effects as possible. This credit identifies several strategies for reducing harm done to the environment over a building's entire life cycle, such as restoring existing buildings, reusing building components, and reducing a building's environmental footprint through LCA. A new energy efficient building will not compensate for the climate change effects of its construction for at best 10 years and perhaps even up to 80 years. Restoring existing buildings preserves a site's historical, cultural, and aesthetic values, and reusing or repurposing wood, brick, steel, stone, or other materials from off site can be a cost effective and sustainable strategy. There are several different options to earn points for this credit. Historic building reuse is the first among the four options for this credit. The historic building reuse will straight away give you 5 points for any building design and construction project or 6 points for a core and shell project. The requirements for this option are: you must maintain the existing building structure envelope and interior non-structural elements of a historic building or contributing building in a historic district. For this, the building must qualify as a historic building by being listed in a local, state, or national register for historic places. You must not demolish any part of the historic building unless deemed necessary for structural reasons. If the building is not subject to historic review, include on the project team a preservation professional who meets US federal qualifications for historic architects. Step by step guidance for option 1. Step 1. Determine whether the building has or is eligible for historic designation. You should search national, state, and local historic registers to determine whether the existing building has historic designation or is within a historic district. If the building does not have historic designation, it may be considered eligible if it meets one of the four National Register criteria or meets state or local historic criteria. Projects outside the US should consult the historic preservation guidelines set forth in the local or national registry of historic places. Step 2. Reuse historic building. Confirm what parts of the building can and cannot be altered to maintain its historic status and ensure that the design and construction uphold these requirements. If your project doesn't fulfill the criteria for option 1, you can try for option 2, renovation of abandoned or blighted building. This option will give you 5 points for a building design and construction project. For this option, you must maintain at least 50% by surface area of the existing building structure, enclosure, and interior structural elements for buildings that meet local criteria of abandoned or are considered blight. The building must be renovated to a state of productive occupancy, and up to 25% of the building surface area may be excluded from credit calculation because of deterioration or damage. Step by step guidance for option 2. Step 1. Determine whether the building is abandoned or blighted. You should determine whether the jurisdiction in which the project is located has a program or designation for abandoned or blighted buildings and whether the building meets this definition. If not, use LEED definition for abandoned or blighted property. Step 2. Determine reusable area. Identify and quantify the surface areas that can and cannot be retained. Step 3. Calculate percentage of reused area. If more than 25% of the building surface area is considered unsound and must be demolished, the project is ineligible for the option but may pursue option 3, building and material reuse. For the calculation, you may use the following equation.
Option 3. Building and material reuse. This option qualifies 2 to 4 points for building design and construction. Reuse or salvage building materials from off-site or on-site as a percentage of the surface area as listed in Table 1. Include structural elements such as floors and roof decking, enclosure materials such as skin and framing, and permanently installed interior elements such as walls, doors, floor coverings, and ceiling systems. Exclude from the calculation window assemblies and any hazardous materials that are remediated as part of the project. Materials contributing toward this credit may not contribute toward MR credit, material disclosure, and optimization. Step-by-step guidance for option 3. Step 1. Calculate existing building surface area and reuse existing building. Identify and quantify the surface areas of the structure, building enclosure, and interior elements that can and cannot be retained. Exclude any hazardous materials that are remediated. Step 2. Reuse off-site materials. Measured in surface area, off-site products and materials may be included in the credit calculations, but may not be double counted for MR credit, building product disclosure, and optimization sourcing of raw materials. Option 2. Step 3. Calculate reuse. Calculate the percentage of total area that will be reused. Here you can see the formula for calculating percentage of existing building reuse. Option 4. Whole building life cycle assessment. This option qualifies 3 points for building design and construction. For new construction, conduct a life cycle assessment of the project structure and enclosure that demonstrates a minimum of 10% reduction compared with the baseline building in at least 3 of the 6 impact categories listed, one of which must be global warming potential. No impact category assessed as part of the life cycle assessment may increase by more than 5% compared with the baseline building. The 6 impact categories are global warming potential, depletion of the stratospheric ozone layer, acidification of land and water sources, eutrophication, formation of the tropospheric ozone, and depletion of non-renewable energy sources. Step-by-step guidance for option 4. Step 1. Calculate existing building surface area and reuse existing building. The LCA must address the following: products, functional equivalents, service life, and system boundary. Step 2. Select appropriate tools and datasets for the LCA assessment. Step 3. Create and model baseline building. Create the baseline building with which the team will compare alternatives early in the design process. Once programmatic and size needs have been determined, input the baseline building into the selected LCA tool. Step 4. Select relevant impact measure systems. Select the appropriate output units for each LCA impact indicator as shown in Table 4. Step 5. Use LCA to make design decisions that reduce environmental impacts. Use the proposed LCA model to conduct what-if scenario analyses to support design decisions to evaluate and select environmentally preferable assemblies and materials. Examples of alternative analyses could include the following: comparing the environmental consequences of building footprint and shape, evaluating different structural system types such as load-bearing walls versus columns, defining the selection of building products and assemblies, optimizing the structural system design. Step 6. Incorporate final LCA results. Review the results, incorporate decisions in design documents, and prepare a narrative that describes the LCA assumptions, scope, and baseline and proposed buildings. Conclusion. This credit qualifies for 2 to 6 points, depending on building type and requirements met. The intent of this credit is to promote reuse of historic and abandoned buildings, reuse of building components, and reduction of a building's environmental footprint. In summary, the Building Lifecycle Impact Reduction has 4 options for achieving this credit: historic building reuse, renovation of abandoned or blighted building, building and material reuse, and whole building lifecycle assessment.